Thank you so much, Ryan. Your shoe is untied. Well, first, thank you for the space, and it's always nice to come out and hang out with everybody here. This is my third major event of the day. I gave a keynote at Token 2049. I also spoke at Hong Kong University, so this is the third event. I also did 5 interviews today, so I am a little tired, but we'll get through it. It's going to be fun. I'll be a little looser, probably say some things that are regrettable, and that's what makes these events enjoyable to attend. It's also nice to have Ken Kodama here, the CEO of Emurgo, a wonderful human being, my counterpart. He kind of runs the consensus of our ecosystem, and they're just doing really phenomenal work with Yoroi and other products. It's just amazing to see how much progress they've made, especially over the last 6 months. It's kind of cool watching an ecosystem go from nothing to something, and watching people actually build stuff and people use the stuff they've built and use it successfully. So that's very humbling. Okay, how many people here have heard of Cardano before? How many people here don't really know very much about it? May have heard of it, but basically need kind of a TLDR. Okay, well, all right. Well, for the benefit of some people, very quickly, Cardano project kind of launched like a DARPA project. So basically, what DARPA does is they say, there is some sort of foundational high-risk, high-return research that we want to do, that if we pull it off, will fundamentally transform something. So, for example, a recent project was called CALO. Has anybody heard of that? Yeah, got you on that one. It stands for Cognitive Assistant Learns and Organizes. Now, does anybody have an iPhone? How many iPhones we got? Now, your iPhone has something built into it. It's called Siri. And Siri comes from CALO. It was actually a military project. So it was 5 years long, from 2003 to 2008. They spent boatloads of money. SRI International was one of the program managers, and they had tons of universities participate. They did a lot of foundational research. They wanted to build this artificially intelligent assistant that could travel with you, either on a laptop or some computing device, and it would be a replacement for a secretary. Okay. Now, it was not accomplished, but yet the people who created that project eventually spun off Siri, got acquired by Apple, and now we have Alexa, and we have Bixby, and we have Cortana, and this is one of the fastest areas growing of artificial intelligence research. So we looked at Cardano as kind of a stretch of, can we build a true third-generation cryptocurrency? So what is that? Well, Bitcoin is a first generation, and it kind of started to show 10 years ago. The point of Bitcoin was saying, we're going to take something that we used to do with a central ledger, and we're going to make it a decentral ledger, and it's going to be done by crazy anonymous people over the internet, and somehow you're going to trust it enough to put money into it, real money, like actual, not $5, but $5,000. That's a really insane concept, if you think about it. Yet, in 2009 to 2013, it went from nothing to about $1 billion of value. And then suddenly people said, this is a pretty good idea. This makes sense to us. Okay. Well, here's what happens when something starts making sense that's crazy. You start wanting to do things with it other than just send it between Alice and Bob. The problem is Bitcoin is kind of blind, deaf, and dumb. It doesn't understand other systems. It can't really do much outside of dumb transactions, and you can't really talk to it. Okay? So in 2013, Vitalik and I, alongside several others, came up with this idea of introducing a programming language to a blockchain. It's almost like when JavaScript came to the web browser. Before that, you could write a website, but they weren't very interesting. You know, they were kind of static. And then suddenly, when you have programmability, you could have Facebook and YouTube and all these other cool experiences. It wasn't designed by Brendan Eich, it wasn't designed by Netscape. They didn't come up with those experiences, but the existence of these tools allowed other people to deliver those experiences to their customers. So analogously, give a programming language to a blockchain, and let's see what people could do with slightly smarter transactions. Okay, we didn't really think Ethereum was going to be very successful. We said, it'll fail in 6 months, and we'll all go do something else, and turned out we were wrong, and what ended up happening was Ethereum became so successful, it actually gave us a collection of problems that we're still contending with in the cryptocurrency space. 3 categories of problems, and this forms the kernel of what Cardano is all about. One is scalability. So basically, first, you have a situation where these systems don't get faster when people join them. So even if you have lots of resources, eventually you have more people than the resources, and you slow down. It's almost like having a big piece of pie at a table. Let's say that table right there. You can add more people around it, but it doesn't make the pie any bigger. So as you add people, the pie gets smaller for every person. These are replicated systems. Bitcoin is like this, Ethereum is like this, and so forth. Now we have other protocols like BitTorrent that are scalable. And what that means is as more people use it, you have the same user experience, or it even gets faster. For example, if you're downloading Game of Thrones, you get it quickly. You download Pee-wee's Playhouse, you get it slowly. Apparently more people like Game of Thrones. Okay, that's a scalable protocol. Is there an analogous protocol that we can come up with in the cryptocurrency space that has those properties? It's an open question. High risk, high return. Second, we do not live in a world where one system is going to replace all other systems. That's called the one blockchain to rule them all, or maximalism. Pick your favorite token, Bitcoin maximalism, etc., etc. Rather, we live in a world where we have legacy financial systems like Samsung Pay and credit cards and debit cards and bank accounts, and also lots of cryptocurrencies. There's well over 3,000 of them. And even after consolidation, we'll still probably end up having dozens of them. Can you imagine a world where we had a different network protocol for every router? You'd have Netgear Wi-Fi and Linksys Wi-Fi and so forth, and your phone can only connect to one? Nothing would work. So instead, the markets very wisely had to standardize on interoperability. So people can build their devices and have their USPs and their brands, but at the same time, you get a guarantee that you can work between them. You can move information, state, value, these things between them. So analogously, we need to achieve that same goal in the cryptocurrency space, the goal of interoperability. We need to move value and information between different ledgers. So that was another one of those high-risk, high-return pieces of research that we wanted to do back in 2015. And then finally, there's the sustainability component of our space. And I don't mean like energy, I mean the who pays and who decides. So we have this thing called the Golden Rule. Does anybody know what the Golden Rule is? We have our first exit. Does anybody know what the Golden Rule is? Show of hands. That's exactly right. He who has the gold makes the rules. Okay. And so here's an example. F# is a programming language, and F# was created by Microsoft. Now, F# is open source and controlled by the F# Foundation. The principal funder of the F# Foundation is Microsoft. Now, as a consequence, do you think that the governance people at the F# Foundation can significantly diverge from Microsoft's business goal brands? Do you think they could just be like, fuck Microsoft, Apple's great, we're just going to do Apple stuff? Probably not, because the money's not going to show up anymore, right? So even though they're independent, even though they're open source, the very fact that they're getting money from someone else kind of influences their behavior, explicitly or implicitly. And we have this issue in the cryptocurrency space. Moving beyond the ICO, we have a situation where a small group of people are patrons and they're basically carrying ecosystems. The Ethereum Foundation and consensus for Ethereum, we got several hegemonies in Bitcoin, and every ecosystem has their custodians. The problem is then you move from a system where it's truly decentralized, whereas it's as open and representative of the population using it as possible, to a situation where you have masters, in some cases silent ones you don't get to see, you don't understand, that may have very different commercial goals than the mainstream users of the system. So that's the who pays problem of sustainability. The other side of sustainability is the who decides. So we got kind of a word salad of cryptocurrencies. We have Bitcoin Cash, Bitcoin Cash SV, Bitcoin Gold, Bitcoin God, Bitcoin ABC, or there's like crazy amounts of it. And we also have Ethereum Classic. What are these? These are, except for the obvious scams, consensus failures, where basically Bob said go left, Alice said go right, they couldn't agree, so they split. That's not a really sustainable system. It's really difficult that every time you run into controversy, you end up fracturing your community into bits. And instead of keeping things together, you end up splitting up. Could you imagine a nation like the United States that every time we have a presidential election, either Texas or California secedes from the Union? They have to be brought back in at some point. That would be insanity. You couldn't run a country like this, and similarly, you can't run a global financial system like this. You have to have a governance system to decide how to make decisions. So these were the three pillars that we really wanted to do some foundational, original research with And as a consequence, we said, let's just go do this in a really rigorous, fun, scientific way. So we got a bunch of university relationships, Tokyo Institute of Technology, University of Edinburgh, University of Athens, and we work with 10 other universities in some way or another. I mean, we have a graduate student, postdoc, or professor we're writing papers with. We've now written more than 40 papers, and more than 20 have gone through peer review at major conferences, like CCS, Eurocrypt, and DSS, Crypto. These are tier 1 conferences, so if you get in a lot, you tend to get tenure at universities. Okay, so we said let's do peer-reviewed science so third parties can actually know if what we're doing is right or wrong. Second, let's extract from those papers specifications that we can then actually write real code from. Formal specifications. So let's use formal methods and peer review. This is the soul of Cardano, the way of like the Ikigai, the thing, the art we practice. Now that's insane if you think about it, because formal methods and peer review, they live on decade-long time horizons. You know, you come up with some major thing, maybe it takes 10 years to percolate. A great example would be the invention of elliptic curve cryptography. Neil Koblitz was the person who came up with that. He was a mathematician trained at Harvard. And Neil came up with it in the 1980s. It took more than a decade for it to actually even be considered seriously. So generally, academia doesn't play in a commercial time frame. And formal methods is the provenance of the aerospace industry, the health industry, where if the software fails, people die or you lose a lot of money. For example, the Boeing 737 MAX that just collapsed in Ethiopia, likely a software issue. Or if one of those probes NASA sends to Mars stops working, you can't go to Mars and kick it to turn it back on. You just got to send another one and spend a lot of money to get it there in time to. So, formal methods are generally used when you have a lot of value at risk, life at risk, and a long time horizon, years to decades. So, to take these concepts that don't map well to startups and put it into a project that's also trying to do big things was pretty crazy. That's why I consider Cardano like a DARPA project. It's high risk, high return. Kalo is, let's invent this artificially intelligent assistant that's almost like the movie Her. We can just talk to it and it can understand us and do cool stuff. Well, even if you don't get there, you probably will get Siri out of it. So there's some merit, there's some value to what we're trying to accomplish. And let's do it in ecosystems that are actually very patient, which is one of the reasons why the principal backers came from Japan, where people kind of get used to the idea that sometimes things take time. If you look at the Shinkansen, there's sometimes families that have been working on it for 3 generations, and they're making plans to extend it up to 2050. So their grandkids are going to be working on those train lines. So, you know, maybe it's okay to have a 5-year time horizon, see what we can accomplish and what we can do. So that's where we started. And it's always started as aspirational. So what have we accomplished? Where have we gone? Well, we were able to launch the first major version of it called Byron in 2017 in September. And basically this was just a kind of a cut down aspirational version of what we'd like Cardano to be. It allowed us to get liquidity, to get listed on exchanges. It allowed us to basically have something in market, customers. We could have a help desk. We could have a QA process. We actually learned how to release software for a cryptocurrency and so forth, which is surprisingly complicated regardless of who you hire or who asserts they know how to do that. And really there is no substitute for time there. In exiting 2018, we consolidated to a very beautiful roadmap. So let's give an accounting of what have we accomplished. Well, in terms of scalability, we have solved a very major problem in computer science. And our belief is, and validated by peer review at major conferences, that we've solved the proof of stake problem. We have a secure proof of stake protocol that matches now the security properties of proof of work pretty well. And that's called Ouroboros. This in itself is probably worth the funding the project received and the time we put in. Now we're just about to roll out the first version of that protocol, Ouroboros Genesis, for a testnet at the end of this month. And very rapidly, that's going to be rolled into Cardano for what's called the Shelley release. So it's going to hit mainnet probably the first half of this year. That's a great accomplishment. But there's more. In terms of interoperability, we first started saying this is a game of both science and pragmatism. The science part is we really don't have good definitions about what is a ledger and how do we move information and value between them and what security properties and privacy properties and performance properties and proof design do I need to maintain. So in essence, you can think abstractly as an interledger transaction as saying you have some sort of source ledger and a destination ledger, and when you send something from the source to the destination, there are 2 questions you have to ask. One is, does the money exist? So if you go from Litecoin to Bitcoin, is it real Litecoin? Two, even if it's real Litecoin, how do I know you didn't double spend it? How do I know you didn't secretly send that Litecoin to Dash or to Ethereum? So you're trying to spend it twice, one to one system, one to the other system. Pretty simple questions. But how do I answer those succinctly? Meaning that I don't have to have a full copy of the blockchain and watch all these different systems and interact with them. Instead, I can transmit a proof that gives me absolute certainty that these two things are right. You have the money, you didn't double spend it, but I know nothing about the state of that system other than that. That's a super hard problem because these systems are abstract. It's not like they're just one design. All these ledgers are different, the rules are different, the consensus mechanisms are different, and so forth. And it's a lot of work. So we built a whole corpus of theory, one for the entire proof of work dimension, and that's called NIPA-POWs, non-interactive proofs of proof of work. And then we did something for the proof of stake dimension, proof of stake sidechains. And we have a new construction called TMS signatures. So these two things actually allow us to now have a way of communicating with other blockchains that support those protocols succinctly, meaning that we do this with kilobyte-ish sized proofs, and you don't need to possess a full copy of the chain. Now, another consequence of this is you get super efficient light clients, because a blockchain is a sidechain to itself. You know, the same proof that allows you to know what a foreign chain can do can allow you to know what your own chain is doing. So you get really nice light clients out of that. Okay, that's the second pillar, interoperability. That's one dimension. The pragmatism side of it is that other people may have other standards, and those standards may win out. So even though we have perfect science, we're the Betamax, sometimes VHS wins. We're the HD DVD, sometimes Blu-ray wins. We're the PlayStation, sometimes Xbox wins, and vice versa, right? So the other side of it is pragmatism, and there's a whole family of protocols, from Interledger, which is what Ripple's working on at the W3C, to Lightning, to things like atomic cross-chain swaps, and basically it's just a matter of paying attention and listening and seeing what the market's doing and who's winning, and adopt that. So we have ours, they have theirs. At the very least, we get Gary light clients, wonderful for accessibility and mobile clients and these things. And best case scenario, everybody else adopts what we have, and then we live in Nirvana paradise. Okay, second pillar. Third pillar is the who pays, who decides. Now this is among the hardest of all the problems, because it's a sociological problem, and a game theoretic problem, as much as it is a technological problem. So first off, we have this demon. It's called rational ignorance. Does anybody know what that is? Oh, come on now. Okay, so let's say you want to have an opinion on the American healthcare system. That's a really complicated system. $2.5 trillion. It's like a big chunk of the U.S. economy. All these people employed. My father is employed. He's a doctor. My grandfather was a doctor. My brother's a doctor. It's like 70 years my family's been involved one way or another in this industry. And what does it mean? It means to be an expert in that industry is to spend a life in it. Do a lot of work. Now here's the problem. Let's say you've done that, and then they say, let's take a vote. My dad's vote counts just as much as the drunken hobo on the street that knows nothing. And that, in a sense, creates an incentives problem in a very particular way, that no matter how much you invest, you get the same payout. So the rational response is to invest the minimum required. Right? Because time is not infinite, it's a resource, it's scarce. So it's actually rational not to be informed about a particular issue. It's rational just to vote randomly or not vote at all. And so any system that requires polling and voting has to have something to make you care. Either we got to pay you, either it's got to directly impact your life. Like you'd probably care about a vote. You know, if somebody was voting to take your house away, you'd probably participate in that vote because you have an incentive, right? So that's one of the first and most dramatic issues with voting. And this is the reason why, year after year, the American election system, and worldwide, suffers from lower and lower participation. Look at the amount of people voted in 2016, it was less than 2012. People voted in 2008, it was less than 2012, and so forth. It's going down. Less and less people are expressing their voice, and they're becoming less and less rational and more shallow in the way that they actually vote. Second, who should vote? We like to be egalitarian, we like to be democratic. So I say, well, okay, that's great. So here's what we're going to do. We're just going to form a random committee and bring a bunch of people together, and they're going to vote on the design for a nuclear reactor that's going to be built right next to your house. Okay. How many people think that's a great idea? You'd say, well, that's crazy. No, we don't want to do that. I said, yes, but you're going to vote in general for a system that decides whether that reactor is built and who gets to build it, and apparently everybody has the qualifications for that. See, this is a big and controversial issue, but it's actually something that needs to be discussed when you're talking about governance of protocols, decentralized decision making. Not necessarily everybody's qualified to have an opinion on everything. So maybe we can create a delegated system where you can give your voice or your power to somebody else. We do this with representative democracies. You say, I'm going to elect the congressman or the community leader. Well, we have a great system called liquid democracy that actually allows you to do that on an issue by issue, on a vote by vote, or for a long period of time, and make it very fluid. Okay, and there's a lot of discussion about that. But it's still an issue, who should vote. And then also, how much should your vote count? How strong should your vote be? So egalitarianism, again, says everybody's equal. So this person's voice is the same as this person's voice. But what if people do more things for society? Like, what if you serve in the military, you become a war hero? Or what if you're a humanitarian, you go save a bunch of orphans in Nuba, or something like that? Or you're just demonstratively a better person. What if you get super educated, like all these advanced degrees? Maybe you're more useful to society. And an egalitarian system says your vote always counts the same as everyone else's, we're all equal. And other systems say you now mean more to society. Also, there's vote by wealth. So we kind of indirectly do this. The rich people have a lot of influence and power because they can donate that money to anybody they want. They can buy ads. They can do all these things poor people can't do. So while technically their vote counts the same, because they have financial resources, they have a much louder, bigger voice. So it's a big controversial issue in the United States about campaign finance. Citizens United was the case that brought in PACs, for example. Well, analogously, what if you could vote with a cryptocurrency by the amount of stake that you have? The richer people in the system, louder, stronger voice. One hand, they probably care about the currency more than you do, because if it fails, they lose a lot more money. For example, we're all complaining about these bad markets. I personally lost about $3 billion in 2018. So when people complain that they've had a hard time, I explain to them that I've probably had a harder time than them. Okay, so certain people care a little bit more. In other cases, that's still not a fair system. So this is why I think this pillar is probably the hardest part of the puzzle. Because in essence, what cryptocurrencies are trying to do is they're trying to establish a system where we can make decisions without a leader. That's really what we're doing. We're saying we have money, we have voting, we have property, we have smart contracts, we have this utility that would normally be a company, would normally be a government, and it normally would have a king, a president, a CEO, a board of directors, executives, hierarchy. And we're just tearing all of that out and now ruling it from the bottom up. Yet we're making the argument that somehow, despite the fact that that doesn't have a king, a CEO, a leader, it will converge to decisions that allow it to sustain itself. In other words, it would be like going to Microsoft, getting rid of Nadella, getting rid of the board, getting rid of Bill Gates, getting rid of all those people, and then somehow Microsoft would still just run and sell its products and build Windows and reliably release on time, and in some cases we would argue it would even make more money and be more sustainable. It's a crazy idea if you really think about it, but that is in essence what the cryptocurrency space is saying. We're going to take a payment system, hosting service, we're going to take all these services that you're used to and run them globally, get rid of the people at the top, yet it will still run. And it still will be just as reliable, if not more so, than what you have. So these are the three things we're trying to solve. Scalability, interoperability, and sustainability. We'll this year get the foundations of decentralization in and be fully decentralized. By numbers, 100 times more decentralized than Bitcoin, about 15 more times more decentralized than EOS, 30 times the transaction throughput of Bitcoin, and about 12 times faster in terms of transaction latency than Bitcoin. Pretty good numbers. And we do that with about 6 kilowatts of power to run the entire system if people are using Rock Pi boards. So while Bitcoin uses all the power of Ecuador or Ireland, we use what's less than a home worth of power. It's a pretty big innovation. In terms of interoperability, we'll have the lightest of light clients. You'll need kilobytes to megabytes to have the same security as a full client. And in terms of governance, that's a hard one. We have a treasury system we've developed, so at least on the who pays side, you can start having meaningful discussions about money. So instead of me or Emurgo or a foundation or some other entity being a custodian of a pool of capital, and you come in and say, oh, Charles, I got this great project, you can submit a ballot to a decentralized account controlled by the network. And then you can make your argument directly to the holders of ADA. Dash innovated this model. We believe we've refined it. We wrote a paper out of Lancaster University from a Chinese professor named Bincheng, really brilliant kid, and that's our first generation model. If we can get high participation there, the next step will be to vote on improvement proposals for the system. Bitcoin has Bitcoin improvement proposals, Ethereum has Ethereum improvement proposals, and we'll have Cardano improvement proposals. So if we get high participation, we can start voting on that, and then we can start experimenting with, can we direct the ship without a captain? So it's been a pretty wild ride. We've met a lot of people. We've gone to a lot of places. Personally, I've gone to well over 50 countries since we started this program. It's been a lot of fun, especially going throughout Africa. I'm going next week to Ethiopia, and we have offices all throughout. We're actually going to be in 25 countries by the end of this year, and all 52 countries by the end of next year. And where we're targeting Cardano's growth and adoption is in the developing world. So at the end of the day, these systems are, if they're actually going to go from being just academic or nice toys or things for crazy people to use to actually things that real people use, you have to ask yourself who cares the most about these things. If you live in Japan or Hong Kong or Colorado or Europe, you probably already have a pretty good financial system. You probably have a bank account. You probably have a credit card. You probably have PayPal. You probably have WeChat, or Alipay or something that allows you to pay stuff. And it probably works pretty well. So then why can't I go to you and say, accept something where you take more responsibility and things go wrong, you can lose your money, and your user experience is not as good? Probably not going to be adopted very rapidly, unless you have very particular concerns. But if you go to Africa, where people pay 35 to 85% interest for a loan, that's $100. Or when their children who live abroad send them money back, it takes a week or 2 weeks to get there, and they have to spend $15 for every $100 they send back. And they don't have a bank account or a digital identity. And it's hard for them to get insurance. It's hard for them to actually get proper documentation on their assets. You're not making an argument that you can beat PayPal or Visa. You're making an argument that you can give them something that they don't currently have. So that's why we have a developing world strategy, a Pan-African strategy, a Southeast Asian strategy, a Latin American strategy. And we're going to try to go and see what kind of innovation we can get, bring the 3 billion people who don't have financial services. So the science side will evolve, and it'll take far more than 5 years to realize all of these protocols. We've made enormous progress, and I'm super proud of that. I'm proud of our partners, proud of what Emurgo's done, proud of what our scientists have done. But ultimately, the soul of the project has always been giving the world a better financial system for those who don't have one. So thank you all for coming, and I'd love to get your questions. Cheers. We have 2 mics, so somebody can either. Okay.
And also it's in back side of Cardano.
This is for you, and this is Jeffrey to the who has questions.
Moon River.
Hi.